Good morning, guys. This is Miss Carsales. Today we're going to look at direct variation. So we've already gone through slope and constant rate of change, and now we're just looking at a proportional, non-proportional direct variation situation. So we've got our definitions. You definitely want to write this down. A relationship that can be represented by a function in the form y equals kx, where k does not equal 0. So before with slope-intercept, we were doing y equals mx plus b. Now we're looking at y equals kx. Constant of variation is the same thing as your slope. Definitely write that down. It'll be on your next test. The k in y equals kx represents the constant of variation or slope. So what makes something direct variation? Y equals kx is a line that goes through 0, 0, and a slope that is k, a constant of variation. So y equals negative 5x would be a direct variation. Any table where you can take the y over x and it gives you the same number each time, that's a direct variation. Again, a number that goes through the origin and just straight line positive, that's a direct variation. A graph that does not go through the origin and is just anywhere else on that graph is not a direct variation. Any y equals equation, so anything with y equals mx plus b or a y-intercept is not a direct variation. Any xy table that, so if I did negative 2 over 0, that would be undefined. Negative 1 over 2 would be negative 1/2. 0 over 4 would be 0. So they don't give me the same number each time. So that would not be a direct variation. So yes, these are direct variations. No, these ones are not. So with direct variation, you have to determine the missing value. So our steps, we need to set up a proportion. The y's are always on top, and we need to solve for the missing value. So suppose y varies directly as x. This is exactly how the questions are always going to be written. Suppose y varies directly as x. If y equals 9 when x equals negative 3, find x when y equals 15. So we're setting up our proportion. Again, y is on top, x's are on bottom. Plug in what you know. I know my first y and x are 9 when x is negative 3. I know that I have a 15, but I don't know the x value that goes with it. So next we are going to do a little bit of cross multiplying and dividing. So when we cross multiply, negative 3 times 15 is negative 45, and then 9 times x is 9x. So negative 45 equals 9x. Then just a one-step equation, divide by 9 on both sides. And you get x is negative 5. And that would be our answer. Okay, so what if we have a table? So a scenario that involves a table. So the following table shows the amount of apples picked in a certain amount of hours. If this rate continues, how many apples will be picked in 20 hours? So that's the wording you need to look for, is if this continues, if this variation continues, if this directly varies and continues at this rate, if it continues. That's the wording you're looking for to tell the difference between a direct variation table and just a slope-intercept table. So most of the time, if I get the table, I'll have 0, 0 for sure. If they don't give you 0, 0, the rest of the points that they give you should simplify down to the same thing. So 21 divided by 3 would be 7, 35 divided by 5 would also be 7. So that's how I know this is a direct variation. I need to choose my points. So really I can choose any point, but I'm going to choose this one, and then obviously the point that I'm looking for. So I have the 20 and I need to find the y value. So proportion and solve. Let's set this up. Remember, y is on top, so 21 over 3, and then y over 20. Again, cross multiply and divide. So 420 equals 3y. Divide by 3 on both sides, and we get y equals 140. So he would pick, or whoever is picking these apples would pick 140 apples in 20 hours. It's a lot of apples. And that's it. Good luck, guys.